Hello everyone, welcome back to YVR Maths tutorial. In this video, I am going to discuss few 1-mark questions from the chapter Continuity and Differentiability on the topic Differentiability, which are asked in the CBSE 2020 board exam in different regions in India. In previous class, we discussed 2020 board exam questions from the same chapter but from the topic Continuity. If you are new to this channel or if you did not subscribe our channel, please hit the like button, subscribe and share with your friends. Without delay, let's begin our class. Look at this question. The greatest integer function defined by f of x is equal to step x, here 0 less than x less than 2 is not differentiable at x. So what is the function they given here? They given f of x is equal to greatest integer function or step x function, and they given the interval x 0 less than x less than 2. What we should find here? At which point the given function f is not differentiable. That means we need to find the value of x where it will be not differentiable. Okay, let us discuss solution for this one. So what is the given function? Given f of x is equal to greatest integer function where the value of x lies between 0 and 2. Now we will discuss about differentiability at x is equal to 1. Now we can check the differentiability at x is equal to 1. In this question, the given function is greatest integer function. So between 0 and 2, what are the integral values we have? Between 0 and 2, we have only one integral value, that is x is equal to 1. That's why we are going to find the differentiability for x is equal to 1. Okay. Now put x is equal to 1 in the given function, then what you will get? Put x is equal to 1, then f of 1 is equal to step 1, that means the greatest integer 1. So what is the step value of 1? 1 only. Okay. Now we can check left differentiability. Left hand differentiation, that means left differentiability at x is equal to 1 we are going to find here. So according to the definition, limit x tends to 1 minus f of x minus f of 1 by x minus 1. So according to the definition, this is the left hand derivative formula. So limit x tends to 1 minus, what is f of x function? F of x function is greatest integer function, that is step x, minus what is f of 1? F of 1 value is 1 by x minus 1 by x minus 1. Now what is the step x value? So before going to identify the step x value, what is the x value here? Here x value is tending to 1 minus. Here x value is tending to 1 minus. What is the meaning of x is tending to 1 minus? X is tending to 1 minus means, x value is less than 1 but x is not equal to 1. X is less than 1 but x is not equal to 1. If x is less than 1, so approximately I am taking 0.9. So if we take 0.9, what is the step of 0.9? Step of 0.9 is 0. So like that, if we take any value below 1 and after 0, that means between 0 and 1, if we take any value, the step of that value is 0 only. So that's why what we will get here? Limit x tends to 1 minus, step x value is 0 minus 1 by x minus 1. That is equal to limit x tends to 1 minus 1 by x minus 1. Now we can substitute the value of x, that means the limit value we can substitute now. So if we substitute limit value, then what we will get? Minus 1 by 1 minus 1, that is equal to minus 1 by 0. Minus 1 by 0 is what? Infinity. That means does not exist. That means does not exist. Okay. So here left hand derivative value, what we got here? Left hand derivative value is does not exist. If one limit value is not exist, then no need to find the right hand derivative part. That means we need not find right hand differentiability, as left hand differentiability is does not exist. From this explanation, what we can say? Therefore f of x is not differentiable. F of x is not differentiable at x is equal to 1. So what is the answer for this question? The given function f of x is equal to step x, the given function f of x is equal to step x in the interval 0 to 2 is not differentiable at integral points. So what is the integer between 0 and 2? 1. That's why at x is equal to 1 it is not differentiable. Okay, I hope you understand. Look at this question. The function f maps R to R given by f of x is equal to minus modulus of x minus 1 is. So they given here 4 options. What is the first option? Continuous as well as differentiable at x equal to 1. Second option, not continuous but differentiable at x equal to 1. Third one, continuous but not differentiable at x equal to 1. Fourth one, neither continuous nor differentiable at x equal to 1. Okay, so before going to discuss the solution of this one, I will show you one graph for the function modulus of x minus 1. Look at here, what is the graph of minus modulus of x minus 1. So look at this graph. So this is the graph of minus modulus of x minus 1. So if we observe this graph, it is very clear. From this graph, the given function minus modulus of x minus 1 is continuous throughout the real number system. But now we need to check at x is equal to 1. At x is equal to 1, it is differentiable or not, that we have to check. Okay. So for that, I am going to discuss differentiability at x is equal to 1 concept. Okay. So I will make this graph as a small diagram. Let us discuss solution for this question. So what is the given function here? The given function is f of x is equal to minus modulus of x minus 1. Okay. Now we know what is the definition of differentiability of the function at a particular point. So a function f of x is said to be differentiable at x is equal to a if limit x tends to a, f of x minus f of a by x minus a exists. X minus a exists. Here limit x tends to a, f of x minus f of a by x minus a can be denoted as f dash of a or value of f dash x or dy by dx at x is equal to a. So this is the definition of differentiability. Now we can check the differentiability at x is equal to 1. Now we can check the differentiability at x is equal to 1. Okay. So before going to check the left differentiability and right differentiability, first we can find what is the value of f at x is equal to 1. Put x is equal to 1, then what is f of 1? F of 1 is equal to minus modulus of 1 minus 1, that is equal to minus modulus of 1 minus 1 is 0, minus 0 is nothing but 0. So now we can find left hand derivative. Left hand derivative can be denoted as L f dash of 1. Left hand derivative at x equal to 1 can be denoted as L f dash of 1. That is equal to limit x tends to 1 minus f of x minus f of a by, here a is 1, f of x minus f of 1 by x minus 1. Okay, that is equal to limit x tends to 1 minus, limit x tends to 1 minus, what is f of x? Minus modulus of x minus 1 minus, what is f of 1? F of 1 value is 0 by x minus 1 by x minus 1. Now what is the value of, or what is modulus of x minus 1? If we observe here, x is tending to 1 minus, x is tending to 1 minus, x is tending to 1 minus means what? X is tending to 1 minus means x value is less than 1, but x is not equal to 1. X is less than 1 means x minus 1 is less than 0. If x minus 1 is less than 0 means what is modulus of x minus 1? Modulus of x minus 1 is equal to minus of x minus 1. So now I can substitute this one in this formula. Then what we will get the new step? That is equal to limit x tends to 1 minus, minus of, what is modulus of x minus 1? Modulus of x minus 1 is minus of x minus 1. So I will write here minus of x minus 1 by denominator part is x minus 1. So from the numerator and the denominator x minus 1 and x minus 1 get cancelled. Then what you have remaining? That is equal to limit x tends to 1 minus, here minus of minus plus 1. So the limit of any constant function is a constant only. That's why the limit of this function is 1. So the left differentiation part, the left hand differentiation part, what we got? 1. Okay. So similarly, we can find right differentiability at the same point. So we will check here right hand differentiability. That is equal to, this can be denoted as R f dash of 1. That is equal to, as per definition, this can be written as limit x tends to 1 plus f of x minus f of 1 by x minus 1. Okay, now that is equal to limit x tends to 1 plus, what is f of x? Minus of modulus of x minus 1 minus f of 1 value 0 by x minus 1. That is equal to, here what is the modulus of x minus 1? See here x value is tending to 1 plus, here x value is tending to 1 plus. If x value is tending to 1 plus means what? X value is tending to 1 plus means x is greater than 1 but x not equal to 1. If x is greater than 1 means what about x minus 1? X minus 1 is greater than 0. If x minus 1 is greater than 0, then modulus of x minus 1 is what? Modulus of x minus 1 is plus x minus 1. So now we can substitute this one in the problem. Then what we will get? See here, limit x tends to 1 plus minus modulus of x minus 1 is x minus 1 only by x minus 1. Observing here, from the numerator and the denominator we have a common term x minus 1, we can cancel. Then the remaining part is limit x tends to 1 plus, we have minus 1. So minus 1 is the constant. Any constant function limit value is constant only. So that's why we got the limit of this function is minus 1. That means right hand differentiation value is minus 1. So we can consider this as equation 2. Now you can observe left hand derivative value we got plus 1. Right hand derivative value we got minus 1. So from equation 1 and equation 2, what we can say? From equation 1 and equation 2, we can say it is not differentiable. So from equation 1 and equation 2, left hand derivative value and right hand derivative value both are not equal. Both are not equal. Therefore, what we can say, f of x is not differentiable. F of x is not differentiable at x is equal to 1. So f of x is not differentiable at x is equal to 1. So now what is the correct option? Look at this. From this graph, we can say it is very clear. The function is continuous throughout the real number system. And based on this explanation, we can say it is not differentiable at x equal to 1. Then what is the correct option? Continuous but not differentiable at x is equal to 1. So option C is correct. Option C is correct. Okay. So I hope you understand. Thank you.